we're going to go into a little bit more detail about how link state protocols work with an eye on OSPF in particular. However, this really is still surface information. We can go a lot deeper, and in fact, we are not going to go into the depth that you need for your CCNA. Each router in this network will send hello packets to its neighbor. Now, hello packets have enough information for the neighbor to decide whether it wants to form a neighborship or an adjacency. So it plays a little game of Mr. Rogers, won't you be my neighbor, right? Now, if certain things are all in a line, that is to say, the same network type, the same hello timer time, which defaults to 10 seconds, the same dead timer time, which defaults to 4 times the hello timer, but they can all be changed. As long as all those are the same, and there's some other things too, but we don't need to get into them, authentication and so on, but primarily those 3 things. If they're all the same, then this router here and this router here will decide to become a neighbor. By the way, these hello packets are sent via multicast address 224.0.0.5, which has been reserved for OSPF, by the way. So it receives a hello packet. It checks to see if it wants to form a neighborship or an adjacency. And I've already given these things, network type, hello timer, and dead timer must all match, and they can all be changed by manual configuration. Once these neighborships are formed, they send out link state requests. They request more information. So each router will send more information to its neighbors. The new neighbor will send out link state advertisements in response to these LSRs or link state requests. So this one has gotten to where it forms a neighbor with this one, and it sends out an LSR or link state request. This one will return the link state advertisement, which tells it all about what networks it's on and the costs and everything it needs to know in order to build its LSDB, or its link state database. The link state database is a map of the entire network. So every router now knows how this entire network is put together. It knows all of the links here, what the speeds are of those links, what networks are connected to what routers, and so on. Once it has all that information in place in the LSDB, it now applies the SPF, or shortest path first algorithm, to the LSDB in order to find the best route to each network. So how do I get to network 192.168.2.0? Well, assuming that all of these are the same cost, it'll go down this short one here, the shortest path, in order to get there. So each router then will write the best routes in its routing table. And by the way, if there's a tie, it will actually add both routes and share them. It'll load balance across 2 different routes. That's something we could not do with distance vector routing.